Hello, everyone. A very warm welcome to all of you, and good evening to all the students who are presently watching this session in the live format. Friends, welcome again on the YouTube channel of Career Launcher. I'm Gaurav Gupta, and I'm one of the mentors of quantitative ability and logical reasoning with Career Launcher. And I've been teaching students who are preparing for MP entrance examinations since last 17 years. Friends, number systems, the concepts of number systems, there are plenty of things that we need to cover in number systems. But how important number system is? I have already discussed the importance of number systems in one of the sessions, the first session of the series that I've taken in the last week, right? Now, the students who were present in that session, they all must have understood the relevance, the importance of number system with respect to different examinations. Now, in that session, I have clarified one basic thing that you might not find a lot of questions, a lot of direct questions on the concepts of number systems, but you will definitely find the usage of number systems in different type of questions, which comes from other topics. The other topics like arithmetic, algebra, permutation, combination, and so on, right? So I can say that number system is the backbone of quantitative ability. If you don't know your numbers, then you will not be able to solve even a single question, right? So taking all these things into consideration that I have discussed in the last session, like if anyone was not present in the first session where I have explained the importance of number systems, so please go back. The session will be available on the YouTube channel of Career Launcher. Okay, so you can have a look at the importance of number systems. So I have discussed the importance. I have discussed the different type of questions, like in what format you can find the questions from number systems. And we have discussed 3-4 questions in that, right? Now today, we will continue from where we have left. We will basically begin this series of sessions with the concept of factors and multiples. Now, this series will have around 10 sessions in which I'll be discussing each and every concept of number systems. So in every session for the first 10 to 15 minutes, I'll be throwing some light on the logics, on the concepts or the formulas that will be used. Okay. And then we will be solving a few questions based on the concept that I have discussed, right? The same thing will happen in every session for the next 10 sessions, right? Now there will be like 1 or 2 sessions every week that I'll be conducting. So you will have to be very regular as far as these sessions are concerned. I will try to increase the number of sessions, but right now I can tell you that there will be maximum 2 sessions. Later on, we'll be increasing the number of sessions for this series. All right. So friends, today, as you can see, we'll be discussing the concept of factors and multiples of a number, right? Now, the students who have already studied the number systems, the students who know some of the formulas which are related to which are related to finding the number of factors of any number, talking about multiples of a number, right? They may be able to understand these things in a much better way. But in case you haven't studied all these things, do not worry at all. The formulas, the concepts that I'll be telling you, you will learn from those, and then you can apply the questions, apply those concepts in the questions that I'll be teaching you. All right. So friends, a very good evening to each and every one of you. So the students who are present here, please acknowledge your presence. Like the same thing I ask the students to do in every session. So Kumar, a warm welcome to you. Good evening. So any other student who is present here, I can see already there are somewhere around 10 students who are watching this session in live format. So a very good evening to all of you. Please show your presence by writing something in the chat box. Come on, go ahead. All right, Rahul, good evening. All right, so let's not wait for other students and let's begin with the first of all, the first 10 minutes in which I'll be discussing some of the concepts. Now, the first thing is finding the number of factors of a number or properties related to the number of factors of a number, right? So I'll be a little quick in this. So to find out the number of factors of a number, so first of all, the first step is you will have to write the number in the form of the prime factorization. So you will have to do the prime factorization of the number, right? So if I take an example, let's say the number is 288. Okay, so I'll do it step by step. So you will have to write 288 as the product of prime numbers, right? So I'll divide 288 by 2, 144, then again by 2, 72, then by 2, 36, 18, 9, 3, and 3, right? So I can write 288 as 2 raised to the power 1, 2, 3, 4, 5, 2 raised to the power 5 multiplied by 3 square. Okay. So likewise, any number can be written as P1 raised to the power A multiplied by P2 raised to the power B multiplied by P3 raised to the power C, and so on, where P1, P2, and P3 are prime numbers and A, B, and C are the powers of prime numbers, right? So this is what we call writing a number as the product of prime factors or prime factorization of a number, right? So if you have any number like this, then the number of factors of this number will be equal to, we will consider the powers A, B, and C. We will add 1 to every power. So A plus 1 multiplied by B plus 1 multiplied by C plus 1, and so on. So this formula, this is how you can find out the number of factors of any number, right? So step number 1, write the number as the product of prime numbers, do the prime factorization of the number. Then whatever are the powers of the prime numbers, add 1 to each and every power and then multiply those numbers, right? So for the example that I've taken on the left hand side, the number of factors will be equal to, consider these powers, 5 plus 1 is 6 multiplied by 2 plus 1 is 3. So 6 multiplied 3, that is 18. 18 will be the number of factors of this number. All right, fine. So this is how we can find out the number of factors. Now there are some very important properties related to the number of factors of any number. The most important property is, if the number is a perfect square, if a number is a perfect square, then its number of factors will always be an odd number, right? So for a perfect square, the number of factors will always be an odd number. And if a number is a non-perfect square, then the number of factors will be an even number, right? So this is a very important property that will be used at a lot of places, right? So this is one thing that you can note down as a property of the number of factors of any number, right? Okay, this was number 1. Now I will erase this property. So I'll erase whatever is there on the screen, or I'll move on to the next slide. Now the next property related to the number of factors, right? So I'll take an example that I've taken earlier, 288. Now 288, as we all know that 288 is not a perfect square, right? So the number of factors of 288 should be an even number, and we calculated the number of factors as 18, right? Fine. 288, the number of factors is 18. Now for 288, the number of factors, or for any number n, the number of factors which are less than under root n, the number of factors which are less than under root n will be equal to number of factors which are greater than under root n. Okay, so in case of 288, under root of 288, the approximate value of under root of 288 will be 16. 16 square is 256, right? 17 square is 289, right? So approximate square root of 288 will be 16 point something, right? So for 288, out of these 18 factors, 9 factors will be less than 16 point something, and 9 factors will be greater than this number, right? So all these factors are equally divided across the square root of that number, right? Fine. Now, in the similar manner, if I take an example of a perfect square, let's say 36, right? So I can write all the factors of 36 quickly. So the factors of 36, 1, 2, 3, or first of all, if I'll calculate the factors of 36, so 36 can be written as 2 square multiplied by 3 square. So the number of factors of 36 will be powers में 1 ऐड करना है 3 multiply 3 that is 9. So there will be 9 factors of 36, right? I can write these factors 1 2 3 4 6 9 12 18 and 36. So these are all the factors of 36. Now what is the value of under root 36? Under root 36 is equal to 6. So 6 is the middle one, right? So number of factors which are less than 6 is equal to the number of factors which are greater than 6. All right. So this is the another property related to the number of factors of a number, right? Now, the next property related to the factors of a number. Okay. So again, I'll take an example of 36, whose factors are 1, 2, 3, 4, 6, 9, 12, 18, and 36. Now, it will happen with every number, not just 36, but it will happen with every number that the product of the smallest factor and the largest factor, the product of first and last factor will be the number itself. So 1 multiplied by 36 is equal to 36. The product of second and second last factor, again, it will be the number itself. The product of third and third last factor, again, it will be the number itself. So the product of factors which are equidistant from both the ends will always give you the number. All right, fine. So the properties that I'm telling you, these properties will help you in determining a lot of things. It will help you in different type of questions. Okay, all right. So these are some properties. These are some properties which are related to finding the number of factors of any number, right? Now let's look at the next thing, the next very important formula. So read this statement: the number of ways of writing a number as the product of two factors. I want to write the number as the product of two factors, right? So the last property that I have told you, that particular property will be helpful in this case. All right, let's check it out. So once again, I'll take different examples. So let's take an example of 56. So the factors of 56, 1, 2, 3 is not the factor, 4. Or if I'll write it 56, 7 into 2 raised to the power 3 multiplied by 7 raised to the power 1. So number of factors will be 8. 4 into 2, 8. So I'm writing all the factors 1, 2, 4, 7, 8, then 14, 28, and 56, right? So this is number 56 with its factors. There are 8 factors. Now, if I want to write 56 as the product of two factors, then it will be the first factor multiplied by the last factor, 1 into 56. Then 2 multiplied by 28, second and second last. 4 multiplied by 14 and 7 multiplied by 8. So the number of factors were 8, and every two factors, the first one and the last one, second and second last, third and third last, every two factors will combine, will multiply, and will give you one way of writing this number as the product of two factors, right? Fine. So I can say that the number of ways will be equal to number of factors divided by 2, right? Now, this particular thing will happen if the number of factors is even, right? If the number of factors is an even number, right? And what type of number has even number of factors? Can you tell me? What type of number will have even number of factors? Come on, write it. If all of you are mentally present in this session, answer to this question. Which type of number will have the number of factors as an even number? Come on. I am waiting. Perfect. Very good. So that shows some of you are present. Non-perfect squares. So if a number is a non-perfect square, its number of factors will be even. And for that particular type of number, if a number is non-perfect square, I can say that the number of ways will be the number of factors divided by 2. All right, fine. Now, what will happen for a perfect square? What will happen if the number of factors is an odd number? We will check it out. Okay, fine. So good. So I can see a response from a lot of you. I loved that. So for a non-perfect square, I can say that number of factors will be, sorry, number of ways will be number of factors divided by 2. Right? Now, what will happen if a number is a perfect square? Okay, perfect square. 36 हमने देखा था एग्जाम्पल. फैक्टर्स आर 1 2 3 4 6 9 12 18 and 36. So 1 and 36 will combine, 2 and 18 will combine, 3 and 12 will combine, 4 and 9 will combine. Now since 36 is a perfect square, so one way of writing 36 will be 6 multiplied by 6. But obviously in the factors I'll be writing 6 only once. Okay, so here the number of factors is 9. So the number of ways for any number like this will be number of factors plus 1 divided by 2. So that is 9 plus 1 divided by 2. There are 5 ways. There are 5 ways of writing 36 as the product of two numbers, as the product of two factors, right? Okay. Now, 5 is the total number of ways of writing 36 as the product of two factors. Now, what will be the answer? Please write it in the chat box. If I'll ask you, what is the number of ways? Listen carefully. The number of ways of writing 36 as the product of two different factors. Number of ways of writing 36 as the product of two different factors. What will be the answer for this? Absolutely good. So I will remove one of the ways. 6 multiply 6, 6 into 6 को हटा देंगे, right? So out of 5 there will be only 4 ways, right? So formula will be number of factors minus 1 divided by 2. 9 minus 1 divided by 2, that is 4. So there will be 4 ways in which 36 can be written as the product of two different numbers. All right. So that was the next formula, number of ways of writing a number as the product of two factors. Okay, Shrey, it will be 4, not 5. Right? 6 multiplies 6. This particular way will not be counted because I want both the factors to be distinct, different. Right? All right. So that was the next formula. Now, the third formula is number of ways of writing a number as the product of two co-prime factors. Now, all of you quickly write, what are co-prime numbers? When can I say that two numbers are co-prime with respect to each other? When can I say two numbers are co-prime with respect to each other? Quickly write your answer. Co-prime numbers. Oh, absolutely. All right. Good. So if the highest common factor of two numbers is 1, or I can say that if the two numbers do not have any common factor except 1, right? So only 1 as the common factors. So two numbers will be co-prime if their highest common factor is 1, or if they don't have any common factor except 1, then the numbers will be co-prime with respect to each other. Absolutely, Shrey. Good. So Shrey has given an example, and pick up any two consecutive numbers. So this is the property of co-prime numbers. Any two consecutive numbers will always be co-prime with respect to each other. This is an easy example. Okay. Right. Now, Shrey, another easy example is pick up any two prime numbers. Okay. 19 and 23. So any two prime numbers will always be co-prime with respect to each other. But your example was easier than my example. Very good, Shrey. Keep it up. Okay. So now I want to write my number as the product of two co-prime factors. How can I do that? Okay. Let's go back and check from the previous examples. Wait. So okay. चलो 36 को लिख ही देते हैं. So I'll do it here. So 36. So 36 is 1 into 36, 2 into 18, 3 into 12, 4 into 9, and 6 into 6. So I have written 36 in a total of 5 ways as the product of two numbers. Now I just have to check if these two numbers are co-prime with respect to each other or not. So first example or first one, 1 and 36, are they co-prime with respect to each other? 1 and 36, are they co-prime? Yes, they are co-prime. So Shrey, another example you can say is 1 will be co-prime with every other number. So 1 and 2 will be co-prime, 1 and 3 will be co-prime, 1 and 4, 1 and 5, 1 and 6. 1 will be co-prime with respect to every number. Okay, so as soon as we'll dig into these concepts, we will start generating some more concepts. Okay, so 1 and 36, yes, they are co-prime. 2 and 18, they are not co-prime because 2 is the common factor. 3 and 12, not co-prime because 3 is the common factor. 4 and 9, they are co-prime, no common factor except 1. 6 and 6, they are not co-prime because the common factor is 2, 3, 6, and so on, right? So number of ways of writing 36 as the product of two co-prime factors is 2. Now I've done this manually. Now let's check it out. What is the formula? So number of ways of writing a number as the product of two co-prime numbers is equal to 2 raised to the power n minus 1. Okay, so note down this formula: 2 raised to the power n minus 1. Minus 1 is in the power itself. Okay, now what is this small n? Small n is number of prime factors of the original number capital N. Okay, so if capital N is, let's say, 36, I can write 36 as 2 raised to the power 2 multiplied by 3 raised to the power 2. Okay, so how many prime factors does 36 have? So 36 के prime factors कौन कौन से हैं? 2 and 3. So the value of small n is equal to 2, the number of prime factors of 36. I'll take one more example after this, right? So for 36, the number of ways of writing it as the product of two co-prime factors will be 2 raised to the power 2 minus 1. That is 2 raised to the power 1, which is 2. So we checked it, it is actually 2, right? The formula is giving the same value. Okay, so this is the formula for writing the number of ways of writing a number as the product of two co-prime factors, right? Let's take another example. So let's say n is 2 raised to the power 5 multiplied by 3 raised to the power 2 multiplied by 7 raised to the power 1 multiplied by 11 raised to the power 2. Let's say this is the prime factorized form of the number. So all of you quickly, first of all, give me the number of factors of this number. Then give me number of ways of writing this number, total number of ways of writing this number as the product of two factors. Then give me the number of ways of writing this number as the product of two co-prime factors. I'm looking for 3 answers. Please calculate all 3 of them and write all 3 answers in the same chat, in the same message, separated by commas. First answer, comma, second answer, comma, third answer. ठीक है? So please do that. All right, so Shrey is the first one to give an answer. Very good, Shrey. Astha, Aranya, very good. And I can see same answers. Wonderful. Lovely, lovely. Lot of you. Shubhra, Meghadri, Janki. Okay, so let's check it out. Number of factors. The first one, looking at the powers, I'll add 1 to every power. So 6 multiply 3 multiply 2 multiply 3. So it is 108. The number of ways will be number of factors divided by 2. 108 divided by 2, that is 54. Number of ways of writing this number as the product of two coprimes will be 2 raised to the power n minus 1, where small n is the number of prime factors. In this case, the number of prime factors are, or the prime factors are 2, 3, 7, and 11. The number is 4. So there are 4 prime factors. So 2 power 4 minus 1, and it will be 2 power 3, that is equal to 8, right? So 8 is the answer for the last one. So 1, 2, 3, 4, 5, 6, 7. 7 students have given a perfect answer of this one. Okay. Now, each of these concepts will be used at different places. I must tell you that the last one, number of ways of writing a number as the product of two coprime factors, this last one will be used as a lovely concept in the questions of LCM and HCF. Okay, so we'll be looking at LCM HCF in one of the sessions. Do not worry at all, and I'll show you the usage of this formula. Okay, so make sure that you are attending every session of number systems. Okay, all right. So these are the three concepts, formulas that I wanted to discuss. Now let's come to the point and start solving the questions. Okay, so question number 1 on your screen. What is the number of factors of the given number 98,784, which are perfect squares but not the multiples of 3? So all the factors of given number which are perfect squares but not the multiples of 3, we'll have to find out. I'll give you 2 minutes. Those who understand the concept, please quickly give me an answer. Okay, any answer for this question? Don't worry if you could not understand the concepts, fine. Okay, I hope you all have understood the logics, the formulas that we have seen up till now. Let's see how to use all of these things to find out the answer of this question, right? Now, friends, the first step will be to do the prime factorization of this number. Okay. So can you give me the prime factorization of this number? So just to save your time, I have the prime factorization. So 2 power 5 multiplied by 3 square. Okay, so Aranya and Shrey, two answers up till now, very good. And 7 cube, right? Shrey, Aranya, and anyone else, please quickly confirm if you have got the same prime factorization. Yes or no? Is this prime factorization okay? Have you got the same thing? Everyone, please quickly confirm if this prime factorization is good. All right, perfect. I've got a confirmation. Yes, this is perfect. Okay. Now, what I want the factors of this number which are perfect squares but not the multiples of 3. Okay. So if I look at the prime factorization of this number, there is some power of 3 that is involved. Okay. So if I'll be writing the factors of this number, then some factors will have powers of 3, some factors will not have powers of 3. That means some factors will be the multiples of 3, some factors will not be the multiples of 3. Okay, but I want only those factors which are not the multiples of 3. So that means I will have to get rid of all the powers of 3. Okay, so I will not be considering any power of 3 while writing the factors of this number. So that means I will be considering only 2 power 5 and 7 power 3. Okay, right? So in the factors of this number, if I remove all the powers of 3, I'll be left with 2 power 5 and 7 power 3. Okay, to generate any factor of the remaining powers, right? To generate any factor, I may use power of 2 as 0 or 1 or 2 or 3 or 4 or 5. So maximum power of 2 that can be used is 2 raised to the power 5. So in any factor of this number, 2 raised power 0, 2 raised power 1, 2 raised power 2, 2 raised power 3, 2 raised power 4, or 2 raised power 5. Any of these powers of 2 can be used. Similarly, any of these powers of 7, 7 raised power 1, 2, 7 raised power 0, 1, 2, and 3. Maximum power of 7 which is available is 3. So I can use the highest power of 7 as 3. Right? Now, to make the factor a perfect square. So in a perfect square, the powers of the prime factors should be even. So if let's say a number is 2 raised to the power 6 multiplied by 3 raised to the power 4, then I can say that this number will be a perfect square because the powers are even. So all the powers should be even for a number to be a perfect square. अगर एक नंबर लिख रहा हूं मैं 2 raised to the power 5 multiplied by 3 raised to the power 4, so this number is not a perfect square because of the odd power of 5. ठीक है, this is a very basic thing. Okay, so I can say that only even powers of 2 and even powers of 7 can be considered. So 2 can be used in 3 ways and 7 can be used in 2 ways. I will multiply them. So the answer will be 3 multiplied 2, that is 6. Okay, so there will be 6 factors of this number which will be perfect square but not the multiples of 3. So the correct answer will be 6. Am I clear with this concept? Yes or no? So the correct answer will be 6. All right. Okay. Now let's move on and look at the next question, a very tricky one. Now question says that n is equal to capital N is equal to 41 multiplied by small n, where it is given that n capital N has 4 factors and small n is a composite number, right? Careful, huh? So n, capital N is equal to 41 multiplied by small n, where n is n has four factors, capital N has four factors, and small n is a composite number. Okay, how many different values of n are possible? Now I'll help you out, ठीक है ना? So n दो बार लिखा हुआ है, small n and capital N. It might be creating a confusion. तो मैं यहाँ पे n की जगह, small n की जगह a कर देता हूँ, ठीक है? Okay. So capital N is equal to 41 multiplied by a. N has four factors and a is a composite number. So how many different values of n are possible? Options are given in this case: 0, 1, 2, 3, or more than 3. Astha, are you asking about 1 as the value of A? Are you asking as 1 as the value of A? If yes, no 1. If 1 is the value of A, then capital N will be equal to 41, right? 41 is a prime number. So number of factors will be 2 for this number. Okay. So 1 cannot be the value of A. Also, 1 is not a prime number. So you are asking, is a perfect square? A is given as composite. A can be any number if it is composite number. Okay, Shrey? So as far as it is composite, you can take any value of A. Okay, you were talking about the previous question. Yes, yes, Astha, 1 will also be considered definitely. 1 is the factor of this number, 1 is the perfect square, and 1 is not the multiple of 3, right? So in the previous question, yes, 1 will be considered. Okay, so Aranya has given an answer of this question, I believe. You are saying that there is no possible value that n can take. All right. Okay. Now, this is like slightly a very slightly logical question. This one is okay. Shubhra is saying 1. Okay, so Shubhra, if you're saying option B is the answer, there is one value of n. So can you give me the value of n? Can you give me that value of n? Shubhra, can you give me that value of n? Come on. So Aranya is safe. Aranya is saying there is no value of n. Okay. Now you are saying that there is one value of n, right? So I want that value of n. And anyone else who has the answer of this question. Now this question will clear a lot of concepts in your mind. Okay. So so Shubhra, you're saying that you have committed a mistake. No problem at all. Okay. So all of you now focus and let's discuss this one. Okay. So I'll be writing some numbers and I want you to give me the number of factors of that number. Right. So let's say the number is 5 multiply 7. What will be the number of factors of this number? What will be the number of factors of this number? 5 power 1, 7 power 1. What will be the number of factors of this number? Quickly. Keep writing, all of you. Absolutely. So number of factors of this number will be 2 multiplied 2, that is 4. Okay. I'll write another number, 41 multiplied by 3. What will be the number of factors of this number? 41 is a prime number. 3 is also a prime number. Shrey, careful. So 41 multiplied by 3, what will be the number of factors of this number? 41 multiplied 3. Okay, again this has 2 multiplied to 4 factors. Okay, now taking an example of this, I can say that if a is a prime number, if a is a prime number, let's say a is 2 or 3 or 5, a is any one of the prime numbers, then the number of factors of n will be 4. But we are strictly given that a is not a prime number, but a is a composite number, right? So I can say that the students who were taking the values of a as any prime number, okay, for them, like bad news for them, they were going on a right track, they were going on a wrong track, right? So a cannot be a prime number, so I cannot make 4 factors of this number in this way. Fine, no problem. I will give you some more examples. Okay, have a look at this. I'm writing a number 27. Can you find out the number of factors of this number? You can do the prime factorization yourself and tell me what will be the number of factors of this number. Absolutely, very good. So you agree that this number has 4 factors. Okay, 27 is 3 raised to the power 3. That is, it will have a number of factors as 3 plus 1, which is 4. Similarly, 8, which can be written as 2 cube, will have 4 factors. All right. And similarly, can I say that the cube of any prime number, the cube of any prime number, right? The cube of any prime number will have 4 factors. Similarly, I can say that 41 cube will have 4 factors, right? So the value of n can also be 41 cube. The value of n can also be 41 cube, or I can write it as 41 multiplied by 41 square, and hence the value of a can be, the value of a can be 41 square. What is 41 square? 41 square is not a prime number but a composite number, right? Fine. So I can say that yes, there is one possible value that a can take, which is 41 square, and hence n will become 41 cube, and n has 4 factors. It qualifies every condition, and we can say that there is one possible value of n. All right, fine. So Shubhra, your answer was correct, but I think you you considered something else. Okay, so this is the correct answer. Option B is the correct answer, and this is the correct logic that I've explained. All right, am I clear? So any number, any number. So look at the bottom of the screen now. Any number of this type, P1 multiplied by P2, product of two different prime numbers, can have 4 factors. right? The example is this and this. Okay, and any number which is a cube of a prime number will also have four factors, right? So the example is this, and a lot of examples are there. Okay, all right, fine. Understood the logical way of solving this? Let's look at one more question. So question says that a number n has 20 factors. Which of the following cannot be the number of factors of the square of n? My God. So a number has 20 factors. It is given. Now I have to find out which of the following cannot be the number of factors of the square of it, of square of n. Yes, Astha, definitely this is the previous question. So are you talking about this one? Please quickly ask me what is the doubt that you have. Be a little quick. Yes, Shubhra, 41 is not a composite number, but A 41 square is a composite number. The square of 41 is a composite number. What is the square of 41? It is 1681. So 1681 is a composite number. Okay, right? Okay, now Asta, you were talking about this one. What is the number of factors of the number which are perfect squares but not the multiples of 3? Tell me what is the doubt. Quickly write the doubt. Astha, do not acknowledge, write your doubt. What is the doubt that you have? Asta, if you want to see anything on this page, this session will be available in the recorded format on the YouTube channel. ठीक है? Will one be considered as a perfect square? Yes, Asta, मैंने explain कर दिया था ना. See this. 1 is a perfect square. Yes, 1 square is equal to 1. 1 is a perfect square. It is not a multiple of 3, and it is the factor of every number. So yes, 1 will be considered. Okay? All right. Now the question, the next one in front of you. I hope, Asta, I have cleared your doubt. Okay. Now a number has 20 factors. Which of the following cannot be the number of factors of the square of n? I'll give you 2 minutes, not more than that. Quickly try to find out the answer. 2 minutes. Yes, Shrey, you are absolutely correct. All of them are odd numbers. So I'll not give you an easy question, a question with such easy options. Like if I'll give you one of the options as an even number, you will be easily able to determine because it's a perfect square. It's a square of n. It's a perfect square. So it has to be. It has to have odd number of factors. Okay. So इतना easy question CAT में नहीं आता. We are preparing for CAT and other MBA entrance examinations. So थोड़ी तो मेहनत करनी पड़ेगी. Okay. Now all of you focus here. Please stop whatever you are doing and focus here. I'm writing some numbers, let's say, of the form a raised to the power 1 multiplied by b raised to the power 9, where a and b are prime numbers. Okay? Assume that a and b are prime numbers. A raised to the power 1, b raised to the power 9. How many factors will it have? Come on, quickly. जो भी मैं नंबर लिखूंगा उसके नंबर ऑफ फैक्टर्स लिखने हैं आपको. You'll have to write the number of factors of every type of number that I'll be writing. A raised to the power 1 multiplied by b raised to the power 9. It has 20 factors, right? So I can write it as the number of factors will be 2 multiplied 10 and it will be equal to 20. Similarly, I'll write another number, a raised to the power 3 multiplied by b raised to the power 4. What will be the number of factors of this number? So 3 and 4, so powers will become 4 multiply 5, that is 20 once again. Okay, right? Similarly, I'll write the number as a raised to the power 19. So a raised to the power 19 is standalone, and 19 plus 1, the number of factors will be 20 once again, right? Similarly, if I write the number as a raised to the power 1 multiplied by b raised to the power 1 multiplied by c raised to the power 4, what will be the number of factors? A, b and c are prime numbers. A raised to the power 1, b raised to the power 1 and c raised to the power 4. So the number of factors will be 2 into 2 into 5 and once again 20, right? Okay. So now how am I able to find or write these numbers? It's not a magic, right? So whatever I'm doing right now, you will have to do the reverse of that number, reverse of that. Okay. So I can say that I can write 20. I can write 20 as, like if I want to express 20 as a single number, I'll write it as 20. Okay. Okay. And from 20, if I'll subtract 1, like if you have this number, we add 1. So if I'm going in the reverse direction, I will subtract 1 from 20. Okay. So I can write 20 as the product of one number only. If I want to write 20 as the product of two numbers, I can write it as 2 multiply 10 or 4 multiply 5. Right? If I want to write 20 as the product of three numbers, it will be 2 multiply 2 multiply 5. I cannot write 20 as the product of four numbers or five numbers, right? So these are four different ways in which 20 can be written as the product of numbers, all right? Now, if I'm writing 20 as this, compare it with this way. So the number will be a raised to the power 19. So if the number will be a raised to the power 19, then it will have 20 factors, right? So this number has 20 factors, so it can be in this form, okay? Then 2 multiplied 10. So how am I able to obtain 2 multiplied 10? When the number was a raised to the power 1 multiplied by b raised to the power 9. Again, subtract 1 each from 2 and 10 and make them the powers of prime numbers. So number can be in this form. Similarly, the other two ways, number can be in this form and in this form. All right. Okay. So this number can be written in these four different ways. I hope I am clear. Okay. Right. Now, if the number is in this form, so I will erase the extra part. I hope you would have understood. Okay. So I'll erase this extra part. So there are four ways in which the number can be formed. So if the number is in this form, then the square of n will be a raised to the power 38. Okay. and it will have 39 factors. So option A cannot be the answer. Similarly, if the number is in this form, so numbers square will be a square multiplied by b raised to the power 18. So the number of factors of this number will be 3 multiplied by 19, that is 57. So option B cannot be the answer. If the number is in the third way, then n square will be a raised to the power 6, b raised to the power 8, and the number of factors will be 7 multiplied 9, that is 63. Option C is removed. If the number is in the last way, n square will be a raised to the power 2, b raised to the power 2, c raised to the power 8, and the number of factors will be 3 multiply 3 multiply 9. Okay, and that is 81. So it also cannot be the fourth way. All right. So the answer will be, so these are the only four possible ways in which a number can have 20 factors. Okay. So option A, B, C, D will be or can be among the number of factors of n square. I wanted to find out which of the following cannot be. So the correct answer will be option E. So option E, 95, cannot be the number of factors of the square of n which has 20 factors. Right, friends? Okay. So friends, that's it about some of the questions, some of the concepts about the number of factors. Now, all the students who are actively participating here, okay, I have a takeaway question for all of you. Okay, I have a takeaway question for all of you. So the question that I'll be showing, you all solve this question and leave your answer in the comment section. Okay, leave your answer in the comment section. So question is, a number n has 41 factors. What will be the number of factors of the cube of n? A number n has 41 factors. What will be the number of factors of the cube of n? All right, fine. So leave your answer in the comment section, whatever your answer is, and I will start the next session with this question. We'll discuss this question first, and then I'll take some more questions of number systems in which the concepts of the factors that I've taught today will be used. These questions may be from algebra. These questions will not be direct questions now. Okay, so these questions will be based on the properties of the number of factors, number of ways of writing a number as the product of two factors, or whatever we have done today. Anything and everything that will be related to the number of factors of a number, right? So this is the question, and you can leave your answers in the comment section. All right, and we'll start with this question in our next class. Okay, I hope you would have enjoyed this session. You would have learned something new in this session. So if you have any comments, if you want to say something, if you want any feedback, if you want to ask any question, please write it in the chat box and we'll be happy to answer those things. Okay, a very thank you very much for being a part of this session. You have been, like always, I can see there are some students who comes regularly in these sessions. And today I can see the other students were also actively participating in this session. A very big round of applause to all of you for this. Thank you very much for being a part of this session. Please do subscribe the channel of Career Launcher MBA. Like this session, please do that. Share this session with your friends and family and keep watching these sessions. All the very best to all of you. Thank you very much. Bye-bye.